Welcome back to part 2 of MapReduce. In the previous video, we looked at how to organize collections, and there is a purpose to that. It will make a lot more sense in this video because in this video we are going to be looking at MapReduce, and we are going to be looking at MapReduce from the purpose or the goal of aggregating data. It should be of note that I do use MapReduce a lot for indexing, like for instance, indexing files. That can be incredibly useful, but that's outside of this context, and there are definitely other contexts in which we can apply MapReduce to. This isn't the only way that we can apply this, but it is one way in which we can apply this. It's very helpful. Okay, so we'll go to our document collection here just for a second, and we'll notice that, of course, as we mentioned, the two documents here, the ID of 2018-0102 and 2018-0103 are different, all right? But let's suppose that we had thousands of documents, and let's just say that we wanted to get the average number of pull-ups done in workout sessions with pull-ups, okay? So this would be something that we could use MapReduce to solve, okay? So when we look at aggregate data, we are often looking at data by a type, a group, and or within or with a filter, okay? So case in point, the average number of pull-ups per workout sessions, where that applies, right? We would get all the sessions with pull-ups and then take the average of the total. What about the total number of loans that have defaulted? We would get all the loans by a default status and add the total amount. And by the way, we can use the principles of math here as well, in that, let's suppose that the aggregate we're using is a minimum or a maximum, okay? Well, if we're using a minimum or a maximum, we can scale that even further horizontally. We'll look at an example of this in a second, just on a list. We're going to actually look at an example in the third part where we're actually digging into it. But we can use the principles of math, because if we're getting a maximum, if I get a maximum of, let's say, I break the data to where it's running processes in parallel, let's say 16 processes in parallel, and each of those 16 gets the maximum number of those 16 different sets. I then put those 16 together and get the maximum. Notice how mathematically I've gotten the maximum of all of the data, right? It's the same thing with the minimum. If I break, let's say, 1 billion records of data, and I break that into 16, or let's just say 20 parts to make it simple, 20 different processes that are getting the minimum of each of their group of data, right? What ends up happening is that when I put those 20 pieces together, again, if I get the minimum of that data set, I've gotten the minimum overall. So that's what I mean by scaling horizontally. You can think about the processes that are running underneath this. There are principles that we can use with mathematics that allow us to effectively use MapReduce. MapReduce is incredibly useful when we think about it in the context of mathematics. MongoDB scales horizontally very easily. We do not need to explicitly create a collection, keep that in mind, or create its schema. Our data within a collection can be different in schema with some similarity, and we can map the similar data together and then perform our aggregates. Now, with tools like Hadoop, we do this on the file level, and yes, we still have to have the ability to read the files. We can't just, magically input anything we want. We still have to be able to read the files so we know what the key and values are. And then, of course, collection organization can help, but we don't have to overthink collections like we do with SQL tables, okay? So I'll give you an example. Let's just use this one really fast here. Would we want to group our workouts with nutrition information, like what we ate for the day? Some people would. My own personal preference would be, and for the record, the answer on this is it depends. My own personal preference would be I would keep that separate. I would have a collection for nutrition, and then I would have a collection for the workouts. But there are some people that would put that there as well, right? The key is that we don't have to do it like this. We don't have to have, this type of workout in table 1, this type of workout in table 2, this type of workout in table 3. Then we have this join table where that's going to be the workout date, etc., right? That's the SQL approach to it, and that's a fine approach. And if we want to do it that way, and in some cases there are definitely types of data that I think SQL makes sense, especially pricing data. But some data like fitness, how are you going to make a report like that? It's going to have to really do a lot of logic on the transform and the load, right? And we saw an example. I was going to see if I could find it really fast. We saw an example of that in one of the slides. Here it is right here, where you see on the very far right side this pull-ups, the set, the jump rope. That would be a pretty report. HTML fits with that. If you try to do that in SQL with a bunch of tables, think about all the joins you'd have to do. Think about the layers upon layers. That's going to be really expensive. MongoDB is going to be faster. Okay, so let's look at some examples where we would apply MapReduce. or where it could be useful. So what about we have, let's see, a collection of homeowners, and we want to know the average home value of homeowners who've defaulted at least once on their mortgage. So what we're trying to get there is we want to know all the homeowners. So we want to first of all get all the homeowners who've defaulted at least once. I said defaulted. I should have said missed a payment at least once. That was my bad. That's my error. So who've missed a payment at least once. What is the average value of homes? Would it be more expensive? Would it be less expensive? And then we can compare that to the average value of homes overall as well as the median. Okay, what about the average ranking of Chinese action movies made in 2017 in a collection of worldwide movies? Okay, so we have a collection of worldwide movies. We want to get all the Chinese action films. So there's two pieces there. It's got to be Chinese and it's got to be an action movie. And then we want to get the ranking. And we want to get the average of the ranking. And then we can see again the principles of mathematics being used here, which is get the maximum number of nuclear energy deaths in 1 year and a collection of deaths related to energy companies. Okay, so let's suppose that all of the different years of energy deaths were in separate collections, right? So we could first of all get all of the energy deaths related to nuclear. So we're going to get all the nuclear, or the deaths, related to nuclear. So filter on the nuclear, get the death number, and then we're going to put it together, right? And we're going to get the maximum, whichever of those years has the maximum, that would be the one that we want to return. So in this case, we could use the principles of mathematics to scale even faster, because we know that or let's say they were grouped by decade. If they were grouped by decade, well, nuclear energy hasn't been around forever. So there would probably be, 6 or 7 collections total if they're grouped by decade. And if we get the maximum number of nuclear energy deaths per decade, then whichever is the maximum of those 7 that are returned, that's the maximum overall. So that's one of the cool things about MapReduce is we can use some of the principles of math in some of these aggregates. Now, I'm well aware that before, everybody screams at me, they're like, yeah, but, some operations you might be looking for, the top percent or whatnot, and you might be limited on that. And there are some advanced algorithms. That's true. But the idea is that going back to this, we don't have the same structure for our documents. So that's the key thing to remember with tools like MongoDB. And I hear this a lot, especially from SQL types, where somebody's like, well, we prefer to use NoSQL. And someone's like, yeah, but then how are you going to organize your schema? And it's like, well, the idea is that your queries are not going to be using these select star from join, right? That your queries are going to be using principles of MapReduce. And that's how you're going to get some of that data. Now, before everyone screams at me, and I already have a video of NoSQL and SQL being best, there are situations in which I will still use both. It's not like one is better than the other. That's not the way it's going to work, at least for me. And none of the data that I've ever worked with only fit one type, in the sense that it's like, yeah, I could use, let's say, pricing data. SQL is better. But then there are data out there that are much better for NoSQL. So MapReduce is one of those examples. In the next video, we're going to be looking at some of this applied, and we would see as well what that will look like as far as scale. Like if we needed to scale, how would we go about doing that?